you go.
Thank you. Hello, everyone. My name's Ben, and I'm an iOS engineer at PlanGrid. First, I wanted to say thanks to JP for inviting me to come speak here, and thanks to Lyft for hosting Slug. Really excited for new Slug. So today, I'm going to talk about a custom decoder we wrote at PlanGrid called JSONObjectDecoder. And to talk about that, I'm going to first discuss some of the, well, actually, I want to get timing going. Make sure I don't go over time. Okay, so first I'm going to talk about sync and how that works at PlanGrid and some of the constraints and issues around doing sync in a mixed language code base that drove us to make this decoder. And then I'm going to talk about how to build a custom decoder using JSONObjectDecoder as an example. And finally, once we have this custom decoder that we can use and kind of build on, I'm going to talk about some improvements that we can make on top of that. So first, for those of you who don't know, PlanGrid is a construction productivity app. So if you are a construction worker on a job site, you typically have lots of paper-based workflows that you work through, like you all might be familiar with, for example, just referencing blueprints to make sure that you're building the right thing. Well, if you're a PlanGrid customer, you use the PlanGrid app on an iPad instead of physical paper, and the PlanGrid app has all of your blueprints, you can file issues in it, et cetera. So that's what PlanGrid's about. And one of the main issues that we face working on the PlanGrid app is that internet on construction sites is bad. And so because of that, PlanGrid works off of a model where we sync all of the users' data for their project that they're working on down to their device so that it's all available offline, and then we will obviously sync it back, any edits you make, back up to PlanGrid when you're back online. And so to give you a sense of the kinds of objects that we sync, I wanted to quickly show a screenshot of the app. So here we are in the PlanGrid app. This is a sample project we have. It's the LA Natural History Museum. And we're just looking at a blueprint. And if you notice on this blueprint, there are all kinds of markups and annotations on it. And so starting in the top left, we have this photo icon. This is a photo annotation. And if you tap on this, you would see photos that somebody took at that place on the job site. Although, of course, here we have photos of the floor sideways in my apartment. And then here we have an issue stamp. If you tap on this, you will see issue details. So here, there's some kind of issue at this place on the plan, something that needs to be fixed or was maybe installed improperly. Anyway, I think most of you all here are generally familiar with issue management. So that's what this is about. And then finally, we have all these other kinds of shape or drawing type markups or annotations. So these are the different kinds of things that we sync in PlanGrid. So when you actually press go to start, to sync down some data, I have this Gantt-like chart to kind of illustrate that. So time goes from left to right. So we get started by downloading some metadata about your sheets, annotations, and issues, for example. And as we download those, we're going to get URLs that point to binary assets. So those photos that you saw, possibly documents that have diagrams in them for something you're installing, and then also the sheet images themselves. And so the takeaway here is that as we're downloading all this data, we are saving that data to SQLite, that metadata. And then as we're doing that, we start more requests to download more metadata. And as all of that's going on, we're also creating NS operations to download files. And some PlanGrid projects, the binary assets and metadata all combined is in the tens of gigabytes. The largest one I've seen was around 66 gigabytes. So the point here is that during sync, the system is under pretty heavy load. Now, some of these requests, these API requests, were written back when PlanGrid was first written for the original iPad. Thanks, Benji. Yeah, first written for the original iPad. So that means that they are written in Obj-C. And since they were written so long ago, they're likely pointing at maybe a deprecated API endpoint. So that's not something that we're going to convert to Swift, because eventually we're going to write something new that points to a newer endpoint that we're going to migrate to. So the point here is that this code is staying where it is, and we're going to live with it until we migrate it to the Swift side of the code base. And so that means from the Objective-C side, we're going to get back are these decoded JSON responses that come down as NS dictionaries on the Objective-C side. And to Swift, this looks like string any. Now, we write all of our models in Swift, and we like to keep that part of our code base, the Swift side, separated from those legacy objects. So the task becomes, how do we get the already decoded Objective-C NS dictionaries into our decodable objects? Well, we have JSON decoder. We could use that, but it takes data, so it decodes JSON from data. And to do that, we would need to take our string any, push it back through JSON serialization, get our data back, and then we can go through JSON decoder and the whole decodable lifecycle. But it would be really great if we could go from our NS dictionary straight to our decodable types. So that is where we're at. And as I explained earlier, while sync is going on, the PlanGrid app is under pretty heavy load, so we are running on kind of a tight memory budget. And right now, the memory budget accounts for the legacy JSON response, and it also accounts for the models. And one of the problems here is that it doesn't actually account for, we don't really have enough room in our budget to say, basically make an entire new copy of our JSON response that we just downloaded in the form of that data just to go back through our decodable types. So this was the impetus and sort of decision-making around why we decided to make JSONObjectDecoder. Skipped around. JSONObjectDecoder. It's a decoder that allows us to decode straight from these NS dictionaries into our decodable types. So now I'm going to talk about building JSONObjectDecoder, or just building a custom decoder in general, using this as an example. And we can't talk about building a decoder without talking about the Decodable protocol. This is the decoder. For those of you who don't know, this is the protocol you implement for your model. And it's the interface that Decoder will use to initialize your models that you're decoding. And so just as a refresher, this is what the Decodable protocol looks like. It just has a single initializer where you initialize it with your decoder. And so to talk more about Decodable and work our way towards the decoder itself, I just have this simple model here. It's a model. It has a title that has a string type. And because the model's properties are themselves decodable, Swift will automatically and very nicely automatically synthesize the decodable implementation for you. And this is really great because the decodable implementation that is synthesized is relatively format agnostic. So the power here comes into play when you build custom decoders or use other decoders that allow you to translate your models between different data formats. And so to illustrate what's going on here and kind of analyze the high-level steps, I've written out what the decodable implementation might look like for our model. And so the two high-level steps that I want you to remember before we dig into decoder itself are, the first step is we want to extract a container from our decoder. And that's the container that wraps the actual data that we're going to extract and pull into our model. And then we extract data from that container. So here we're pulling the string out for the title key. All right, so it's those two steps. And this kind of illustrates the dance that happens between decoder and decodable. Decoder provides these containers that wrap your data, and Decodable calls these decode methods on those containers that were provided. All right, so the first step is in implementing, that we're going to think about when implementing our decoder is getting a container. Now for JSONObjectDecoder, we can draw parallels between these methods and the actual NS dictionary or NS array types. So this first method, container keyed by, this is going to return a keyed container, and that roughly maps to a dictionary inside of our JSON object. So that's going to wrap our dictionaries. Unkeyed containers, in this case, are roughly going to wrap arrays, and then we have a single value containers that you can use to wrap anything else. All right, so when we're talking about getting a container, there are three important protocols. the key decoding container protocol, unkey decoding container, and single value decoding container. And when you implement a custom decoder, you basically have to implement all of these. And specifics aside, this all essentially boils down to implementing a lot of methods that start with decode. And when I say a lot, I mean there are really a ton. So this is all of them. From left to right, we have key decoding container, then unkeyed decoding container, and then single value decoding container. Now this looks kind of crazy and scary and seems like a lot of work, but I'm going to try and break it down and help us build a mental model so that we can work through this. It actually gets a little bit simpler. So the first thing to recognize is that all of these models have decode methods for decoding what you might often see referred to as trivial types. So that's your floating point types, fixed width integers, other numeric types, Booleans, strings, etc. So those are all shared across all three of these. And then they also all have a generic decode method for decoding any type that conforms to decodable. And then finally, our keyed and unkeyed containers. Those have decode if present variants of all of those that I just described. And all of those do, so for the keyed container, decode if present will return nil if the key is missing. Decode if present for the unkeyed array. So for each time you call decode on an unkeyed container, it moves on to the next element in your unkeyed structure, in this case an array. And decode if present just returns nil if you're at the end, or if there's no more elements left to decode. And then finally, I'm not going to go into these in too much detail today, but down at the bottom, there are some other methods, nested container, nested unkeyed container, and nested container. As you can imagine, those return containers, other containers that are nested within your JSON structure. All right, so moving up right along, let's move on to the second step, which is extracting data from your container. And we're going to do that by basically building one of these decode methods. So we'll tackle trivial types first. And you'll note that most of the work can be done by one helper function. And the way the function works is this. We basically attempt to get a value of the requested key or index when someone calls decode on one of these containers. And then we're going to attempt to cast it to the value of the requested return type of that value. And so I'm going to show you what that looks like. So here is the keyed. I'm going to use the keyed container as my example. So this says value for key. It's a little high up there. And the first step, we just attempt to get the value for specified key. So we're looking into the dictionary, attempt to extract the value. If it's missing, we throw an error. And then the second part is we attempt to cast the value to the return type. If that doesn't work, we also throw an error, and then we return. It's pretty straightforward. And this, once you implement a method like this, you've done the vast majority of the work for all of your typed methods. And then, once you have that, you can basically just do some copy pasta and implement nearly all of your decode methods for trivial types. And when I first wrote this, it looks kind of funny. I wasn't sure if this was really the right way to go about it. But you can go look at the JSON encoder and JSON decoder in the Apple Swift repo. They use a very similar pattern. There's a lot of copy pasting. All right, so we've covered the trivial types. And now let's look at the decodable types. The process is very similar. We're going to attempt to get a value of the requested key or index, so that function we just implemented. And then we are going to create a decoder that references that value we've just extracted. So again, we are going to create a new JSON object decoder, in this case, referencing that value we just extracted, basically restarting this decoding process at the new level in our JSON data structure. And then we're going to take that and pass it to our decodable types initializer init_from, which they're required to implement. And so the code for that looks like this. Again, we're going to use our self.value for key method and reuse that there, and then we'll initialize the JSON object decoder. Initialize the JSON object decoder referencing that value. Now, there's one other little piece of state tracking I didn't mention, and that is coding path. Coding path is also required for your decoder. And this just keeps track of where you are in your decoding. So basically, if you follow this coding path, it would take you somewhere into your JSON object. So it's an array of maybe like a string that it represents the key, and then an array index that represents the index into that array, and so on and so forth. And this lets you basically debug any issues that go wrong. When you throw errors, the coding path will be there. When you have, when breakpoints hit, you'll be able to look at the coding path and see where that issue occurred. So that's coding path. All right. So I just showed you how to implement extracting data from a container for key decoding container as our main example. But you can repeat these patterns for all of the other protocols. Well, 2 other ones anyway. So for unkeyed decoding container, it's the same thing, except instead of a string key, you're decoding one thing at a time walking through your array. So each time somebody calls decode on your container, you advance the index. You advance an index. And then for single value decoding container, apologies, I'm going to have to say decoding, decoder, container, and a lot of other things a lot. With this one, you're only looking at a single value, so it's even more straightforward. Here, you're basically just leaning on your decodable type to call the appropriate decode method on this container, because it's going to know what value it expects to extract here. All right, so I've covered a lot of the low-level pieces of writing a decoder. And so that's the container methods there, implementing those and their decoded methods. We also talked about coding path. The last missing piece is the user info dictionary. JSONObjectDecoder actually doesn't use this at all, but this is there for you to basically attach any configuration or state about your JSONObjectDecoder that you kind of need to, or about your decoder, that you need to communicate within your decoding system. So maybe between your decoder and your decodable types, et cetera. All right, so now that we have gone over the high level, or some of the lower level pieces of the decoder, zoom back out, look at the JSONObjectDecoder and how it's structured. So here's all of the state for JSONObjectDecoder. We have the required coding path and user info, but then I also want to look at, more specifically, this JSON value. So this is what keeps track of the specific value we are looking at that we're decoding at the current time. So when you initially create the JSONObjectDecoder, this will be pointing at your top level NS dictionary or NS array, for example. And then as you work your way in, creating new decoders, this will point to those, those values deeper into your data structure. And this value type has 2 special cases, array and dictionary, that are important because we're only going to allow creating unkeyed and keyed containers for those 2 special types. All right, and so now here are all the initializers for our JSONObjectDecoder. We have 2 public and 1 private one that you saw me use earlier. Since JSONObjectDecoder is meant to be initialized for top-level JSON structures that you might get from an API, the only 2 that are allowed in the JSON spec there are dictionary and array, so those are our 2 public initializers. And then we have a private initializer that you can initialize with anything, and that is basically just for creating new ones that you're going to create as you traverse your JSON structure. All right, so here's an example of one of our container methods, how they're actually implemented. So this is unkeyed container. Pretty straightforward. We're just going to make sure that the JSON value we're currently decoding is an array, and if it is, then we can unpack it and return a new unkeyed container that wraps it. Otherwise, we throw an error. The keyed version of this looks very similar, except we're going to make sure that it's a dictionary before unpacking it and returning a keyed container for it. And the single value container is even more straightforward. We're just going to take our JSON value, extract whatever value it's holding, and create a new single value container referencing that value. And it's worth mentioning the JSON, this whole creating new decoder and referencing the current value you're looking at and creating it as you work your way through. This is very similar to the JSON decoder, like Apple's Swift JSON decoder, except they have an intermediary private class that is basically this. Using a single class to do all of this at once was just a little bit easier to implement. Finally, we have our decode method, pretty straightforward. This is for decoding anything that is decodable, and this just starts the whole decoder decodable dance by initializing that first type with self being the decoder we've set up. And yeah, this is just what I said. It starts this process, and again, those two high-level steps that I keep repeating are, your decoder is going to start calling methods to get containers, and then start calling decode methods on those containers. So just a review, we talked about building a decoder. We used JSONObjectDecoder as an example. And if there's anything you take away from this, is that the decoding system is a lot about this dance between decoder and decodable. Decoder provides all the containers that wrap your data, and Decodeable is going to call those decode methods to extract the data it needs. And if you remember this, the synthesized and the code that you write for your decodable, it's all format agnostic. So again, it's all about the kinds of decoders that you write or use in terms of the formats you can translate your models between. All right, so now that we have this decoder, JSONObjectDecoder, I want to talk about some improvements that we can make to it, because now we have this interesting thing that we can play around with. And to talk about that, I first want to talk about some of the limitations around JSON-Decoder and JSONObjectDecoder, because they have pretty similar APIs, slightly different approaches, but similar APIs, and therefore similar limitations. So the one I want to focus on is that JSON-Decoder and JSONObjectDecoder decode objects one at a time. And what I mean by this is if you look at unkeyed decoding container, for example, with this, you're going to, every time you call decode, you can decode one object in the array, and it moves on serially. And that means we're not really taking advantage of the fact that devices have multiple cores. More often than not, you can, if you have the right sort of setup and the right size data and all of these things, you can take advantage of multiple cores and parse your data a lot faster. And one of the main differences between JSON-Decoder and JSONObjectDecoder is that we have this nice structured intermediary format, those dictionaries and arrays, whereas JSON-Decoder is working with opaque data. So it's a little bit harder and trickier to kind of work something in like that that can't just decode one at a time as it begins to understand its data. How did I go back a slide? Okay. Yeah, so we have these this nice structured data formats, and a dictionary of string any and an array of any. And so we can take advantage of this and use something like dispatch queue concurrent perform to map decodable initializers across all of the values in our top level array if we say get an API response that has an array of objects that we want to decode. And if you're not familiar with this API, dispatch queue concurrent perform is a synchronous or blocking API. And it just calls the closure that you pass it n number of times, and you pass one of the arguments is the number of times you want it to be called. And it load balances those calls concurrently based on system load. And the only argument you get is the index that represents the iteration point. So if you have, let's say, an array of size 10, it's going to call that block 10 times. Each time it'll be like 0, 4, 3, 2, whatever place it's looking for you to get at in the size and that you passed it. All right, so to demonstrate this, I'm going to use live coding because it's slug. Okay, so switch over here to my Xcode project. Jesse, I'm sorry I didn't make a playground. And here I have made a method, the high level, bones but no implementation, almost no implementation method, concurrent decode. And concurrent decode, it's meant to return an array of decodable types. And here I've opted to pass the errors up through this out parameter so that I can basically decode everything and then pass up any errors that might have happened decoding one of those objects as we went through. I could have decided to make this, I could have removed that and aborted the whole thing by just throwing an error as soon as, oh, yeah, that'd be great. Yeah, so I could have designed this differently and removed that and just aborted everything as soon as I encountered a single error. This is the design I opted to do for this talk. Sweet. Thank you. That's very helpful. OK, so I still have a little bit of time, so I'm going to try and write this method. So first, we're going to make the array that is going to have all of our results in it. It's going to be an array of our decodable types. And I'll go ahead and size this array, or make sure it has enough room to store all of the values that we expect to decode. So values.count. And again, hopefully you saw this, I did my type checking there to make sure, this method is only going to work if we're looking at a top-level array. So I go ahead and check that and throw an error if that's not the case. And then I'm going to go ahead and use dispatch_queue.concurrencePerform. I'm going to pass it the number of times I want it to be called, in this case, value.count. And I'll go ahead and make my index I. And so each time this is called, I'm going to extract a value from my values array. Oops. And then once I have my value, I'm going to go ahead and create a decoder. So decoder equals JSONObjectDecoder. Swift, of course, is not going to help me with this, so I guess I'll do it myself. So yeah, I'm initializing with this value I extracted, passing it my coding path. Plus, I have this struct that just implements coding key that wraps an integer key. So right now we're jumping into whatever we are in the coding path right now, plus this array index. And then I'm going to go ahead and make a do catch, since we're about to get to the part that can error. And if there's an error, I'm going to go ahead and just do errors.append error. Great. I'm going to do let decoded value equals try t from decoder. Great. And then I'll do result array append decoded value. And then outside of this, this will be populated, so it'll be return results array. Great. So now we have kind of the bones of this method here. Yes, there is a return there, so thank you, Xcode. OK, the only piece I'm missing is that since this can happen concurrently, I need some kind of lock. So I'll go ahead and make a lock. I'll just use unfair lock for this. I'll do OS unfair lock. Lock. Defer. And that's it. That is concurrent decode. Basically, concurrent, we're making a bunch of JSON object decoders and essentially mapping, initializing all of our objects based on whatever load and whatever concurrent perform decides to do. All right. So that is improving our decoder. We basically just took advantage of the fact that we have this nice data structure, and we can do more interesting things with it than, say, you could very easily with JSON decoder. All right. So just to review, Sync at PlanGrid has some challenges. Some of them have to do with just general memory budget and load constraints. Some of them sometimes have to do with the fact that we're still in a mixed language code base. We still have legacy APIs that we have to work with. And sometimes it's the combination of both. We talked about how to build a decoder. I used JSONObjectDecoder as my example. And then I talked about how to make a small improvement there with our dispatch queue concurrent perform API. And so that's it. Just under 30 minutes, I think. Here's some links. Here's just the link to the Swift JSON decoder /encoder. Here's a link to an open source version of what I just did, which I learned about after JP sent it to me when I proposed this talk. Thanks, JP. And then JSONObjectDecoder implementation is up there as a gist. It's not as an open source repo, unfortunately, because it's for legacy APIs, so we would like to get rid of it eventually. But yeah, that's there. And this is how you can contact me if you want to contact me. If you have any questions, I'd be happy to take them.
All right, thank you, Ben, for that talk. If you have questions, just raise your hand, and I'll run after you.
Kind of not. Oh, sorry, I'm not used to talking to the microphone.
Sure.
A little off topic, but why did you choose to use a lock instead of, say, a serial queue to serialize access to the result array and the errors array?
Yeah, sure, definitely. Yeah, so you could certainly, both would work. You could use a serial queue. Lately, there's been a lot of focus around not creating too many extra queues because of dispatch queues overcommit behavior. So when you ask it to dispatch something, yeah, all dispatch queues, again, go up to, and if you're not familiar with target queues, all dispatch queues target one of the global queues. That means eventually they're going to make it up to global queue, and it'll make the kernel create a thread. It will always create a thread because of the overcommit behavior. There's a lot of talks about it in WWC this year, so you should watch them. Yeah, for these kinds of scenarios, they typically recommend just trying a lock first. It's pretty, OS unfair lock is also particularly lightweight. Peter Steinberger, I think that's how you say his last name, has some really great benchmarks somewhere in a gist that kind of describes them too. Yeah, both perfectly usable choices. This one is also much, I had actually originally had a version that used a queue. This one's much easier to demo with. Yeah.
Hello.
Hey.
Question about the memory of decoder.
Should I go somewhere? No.
No, this is just kind of in your experience.
Cool.
Because if I have, so hypothetical worst case scenario in my mind is like I have a JSON object which is very deeply nested, and at each level I just have one key and then like the dictionary that's inside. So there's like, one number, but it's just like a million keys.
A million keys deep, okay.
So does decoder like make a decoder for this level and then make a decoder for the second level and then make a decoder for the third level? So do I have like a million decoders and then they have to like bubble all the way back up, or how does the memory
Okay, so are you
work?
asking me about Apple's Swift implementation?
Sure. I don't know.
Okay.
I mean, I haven't used Decodeable a ton, or especially
Sure.
not with like kind of anything beyond super trivial.
Yeah.
So just, does it get super slow if I have deeper nesting as opposed to shallower nesting, or?
Yeah, so I'm trying to remember exactly how Apple's works. Apple has an internal decoder. Okay, so Apple's, you don't have to initialize the decoder with anything. You just create it, configure it, and then call decode with your, with whatever you're decoding, the data. And then they have an internal decoder that looks more like mine, where you initialize it with, it's like the initializer says like referencing, so referencing the value that you're decoding. I can't remember if they create one every time off the top of my head, or if they do something where they use the current one, but then like push on the coding. I kind of remember them like pushing on a coding onto their coding path array and then popping when they're done. Okay. In which case it would use less.
Cool.
Yeah, so you could do both. In our case in particular, our things are usually pretty shallow. It's like an array of top-level objects, and we just need to parse those. So.
Hey, I think of decoding as a pretty stateless operation. I was curious what you're passing and what you're doing with the user info.
Sure. I'm not actually, so I don't do anything with the user info. Shoot. So user info, it just says it's used for storing any contextual information set by the user for decoding. So it's pretty vague. I'd imagine if after you initialized and set up your JSON decoder and printed out the contents of the dictionary, like Apple's one, you would find some like configuration information that might be passed down to other internal things. But that's just a guess. That's what I would expect to be there. But yeah, personally, I didn't have any use for it. Yeah, I agree. Relatively stateless.
We'll do two more, so one after this one.
Great talk, Ben. Thanks. Does the organization you work for by any chance offer employment opportunities?
Oh, wow. So glad, person I've never met before, that you asked that. Yes, my team at PlanGrid is hiring, and you can email me or contact me using either of those points of contact there.
Any last questions? All right. Big thanks to Ben.